Hello, I am a group of students from River Valley High School, and today we will be delving deeper into the physics in basketball. This is David. David likes basketball. Here is David playing basketball.
Hang on the rim, hang on the rim.
Anyway, today we are first going to be investigating the projectile motion of shooting a ball. Let's say you were to drop the ball directly onto David's head. The ball is in a vertical motion. Here, rolling the ball along the floor is a horizontal motion. However, when we launch the ball for a shot, this is a projectile motion. A projectile motion is when an object moves along a curved path under the influence of gravity. When David shoots the ball, the object moves in a parabolic path with a vertical and horizontal motion that are independent of one another. Thus, we can use separate equations to account for the motion in each direction. If David shoots the ball such that it only has a vertical motion, it will look something like this. If he shot the ball with only a horizontal motion, it will look something like this. Therefore, a ball is shot in a parabolic path in basketball. The concept of a projectile motion is relevant to players because the arc of the shot would vary for different distances. According to sports scientists, shooting the ball at 52 degrees is the optimum angle for a free throw to minimize the amount of strength needed. As one moves further away from the rim, in order for the ball to enter the hoop at the same angle, the angle of projection must increase.
When shooting a free throw or a 2-point shot, one could easily shoot the ball with only his arm strength. However, when shooting a shot from a further distance, in order to provide sufficient force for the ball to reach the hoop, a player might jump upwards to increase the vertical velocity of the ball. If David were to shoot the ball without jumping, the force required for the ball to reach the basket would have to come from his arms completely. The velocity of the ball would be completely dependent on the velocity of his arms and the force exerted by his hand on the ball. That said, if David were to jump and release the ball, the amount of force his arms would have to produce will change. Because the ball is already rising at a velocity along with David's whole body, his arms will have to exert a smaller vertical force on the ball. However, releasing the ball at the wrong timing will affect the force required to shoot the ball. Since the ball is moving together with David until the point of release, the ball will have the same velocity as David until then. However, if the ball was released at the maximum point of the jump, David would have a velocity of 0, and in real life, he would more likely already be moving downwards. Thus, the ball would have a downward velocity, and the arm would have to produce an even greater force in order to launch the ball so that it has the optimum arc. Now, let us move on to the next part of shooting a basketball, adding a spin.
The presence of a spin in the ball is also a relevant factor in whether or not you will make your basket. Newton's third law of motion states that for every action, there is an equal and opposite reaction. If one shoots the ball without a spin and the ball hits the rim, it will bounce high and away from the hoop. This is because at the point of contact with the rim, the ball experiences a normal force perpendicular to the surface of the rim. Here, David shoots a free throw without any spin in his shot. When the ball comes into contact with the rim, it experiences a normal contact force upwards as it exerts a downward force on the rim. Despite not having any spin in his shot, he makes the next free throw here because the ball goes in cleanly without touching the rim. On the other hand, here is what happens when someone shoots with a spin in their shot. Most players train themselves to add a spin to the ball when they shoot, because this will affect the way the ball bounces off the rim. Notice how even though the ball came into contact with the rim at a similar position to David's missed shot, the ball slowed down and went into the hoop. In this case, when the ball comes into contact with the surface of the rim, it slides across the surface, and thus not only experiences a normal force, but also experiences frictional force. Because there is a greater tendency for the ball to be hitting the inside of the back rim during a missed shot rather than its outer surface, there will be a frictional force that acts downwards as the ball spins upwards against the rim. This would reduce the upward force being exerted on the ball and cause the ball to lose kinetic energy. In conclusion, here is how you can shoot the perfect shot. Number 1. Having the right angle of projection. Number 2. Releasing the ball just before the highest point of the jump. And lastly, having a spin on the ball. However, as you can see from all of David's missed free throws, the most important thing that you should be doing is to repeatedly practice to achieve perfection. Physics can only get you so far. Thank you.
Okay, we are done.